Okay. The last part of Chapter 7, the last part of the systems unit dealt with graphing inequalities and systems of inequalities. So 47 and 48 47 and 48 are inequalities in two variables that we need to try to graph, and then 49 and 50 are systems. So graphing inequalities is 47, 48. Graphing systems is 49 and 50. I'll go ahead and do all of these. So remember, that's a two-part process. You start by finding the boundary, graphing the equation, x minus y equals 4. So if I put a 0 in for y, x would be -4. Okay. If I put in a 0 for x, if I put that in, -y would equal -4. And if I divide by -1, y equals 4. That would be 4. Okay. So over here would be -4. And up here would be 0, 4. So that line would be connecting those two. You see how it's greater than? This is dashed. Okay? Because it doesn't have the or equal to. Now we need to do a test point. So the next thing we're going to do is we're going to test a point that's not on the line. Test a point not on the line, like 0, 0. Put it in the inequality. So your inequality was this. Put in a 0 for x and a 0 for y, because that's the point I chose to test. And I would get 0 greater than -4 is what I'm wondering. And 0 is greater than -4. The answer is yes, which means this worked, which means you got to shade that side. Okay, so that would be the picture for that inequality. Any ordered pair that's in that shaded region would satisfy the inequality. And the points on the line don't. That's why they're dashed. Okay, now on 48, there's an or equal to, so the line will be solid. So on the points on the line will work. Okay. 2x plus y equals -2. So if you put a 0 in for x, y would be -2. I can see that without much work. If I put a 0 in for y, you might need to think about that a little more. Okay. Then the x would be -1. So here's -1, 0, here's 0, -2, and the line should be solid. And that solid means the points on the line actually are ordered pairs that satisfy the equation. But you got to remember to also shade. So you can pick any point on either side of that line. If 0, 0 is available, it's a really good one. So we're looking for the shading now, right? So I'm going to test 0, 0. So I'm going to put in a 0 for the x and a 0 for the y and see if that works. So that's 0 less than or equal to -2. Ooh, the answer to that is no, right? If you looked at it, 0 is bigger. It's more to the right, so the answer would be no. That means I don't shade towards that point, I shade away from it. Okay, so that should be the answer to 48. Okay, so that's graphing inequalities. It's a two-step process. You graph the line, which is the boundary, and then you test a point to decide which side to shade. Okay. All right, so now we got just 2 more questions, and then you can really get busy on all this material. All right, we're going to look at 49 and 50. Okay, there we go. All right, so on 49, we're graphing the system of inequality. So we have actually 2 inequalities that we have to graph. And on 50, we do as well. Okay. All right, so what you're going to do is you're going to take one of them at a time. You're going to first graph the boundary, then determine your shading. Then you're going to think about the other one. Oops, you write the original. Okay, and then you're going to, after you do that, you're going to determine the shading. And these both are going to be put on the same coordinate plane. Okay. All right, so look, the graphing of this, you just need to find some ordered pairs that work. So if I put a 0 in for x, y I can see would have to be 4, because 0 would knock that out, so the y would be 4. If I put a 2 in for x, y would have to be 0. So here's 0, 4. It's on the y-axis. Here's 2, 0. It's on the x-axis. Okay. And then I want that to be solid here. Actually, this one was supposed to be or equal to also. I just wrote that wrong. So it's solid as well when I get around to it. So I'm doing this guy in blue. So here's the line. It's solid through those 2 points. Okay, now for the shading, I'm going to test 0, 0. So when I plug in 0, 0 into the inequality, the reason I like to use 0, 0 is it completely knocks out that left side. It turns out to be 0. And I'm asking if that's true. Is 0 less than or equal to 4? And the answer is yes. Really, I'm testing, is it less than 4? And the answer is yes. Here's 0, 0, and the answer was yes. So that means I want that side. Okay. But I don't want to do the big shading on this because I really have to wait till I get the other one graphed to see where the final order pairs are going to be. So now I'm going to do this one in red. So I have to graph the line y minus 1 equals 0. So I'm going to add 1 to both sides. So y equaling 1. Y equaling 1 means all the y's are 1. So you're going to be up here at 1. Oops, I meant to do it in red. Let me do it in red. Come on, there we go. All right, so that side I'm doing in red. All the y's are 1. It was solid because it had the or equal to on it. And this one I don't know that you need to necessarily test, but like y, I'm looking for where is y less than or equal to 1. So I know it's got to be this way. Not stopping at the x-axis, keep going, but that way. So then see where it intersects and how you have those 4 regions. You're looking for where is the arrow in both. So your answer where you would have dropped the bucket, trying to change to black, there we go, is right here in this region. So your answers would be all the points on that part of that line, all the points on this part of this line, because they were both solid, and then all the points in that region there. Okay. All right. So let's look at number 50, and then I'll get this posted. All right, so we got two inequalities. Y greater than negative 3x plus 1, and then I'll do the other one in blue. X minus y greater than or equal to 1. Okay, so I'm going to do two things. I'm going to graph the line. Then I'm going to shade, figure out the shading. And over here, I'm going to do the same thing. I'm going to graph the line. Okay, then I'm going to determine the shading. So let me get my coordinate plane here. Okay, so when I graph that line, I might put a 0 in for x, which means I'd get a 1. If I put a 1 in for x, that would be negative 3 plus 1 would be negative 2. Okay, so 0, 1, and then 1, negative 2. Or I could have begun at 1 and moved down 3 to the right 1. We do that again and get that done. It's going to be dashed because there's no or equal to. Okay. All right, now look, when I did that, you know, it's all scrunched up right there. It's hard to see the 0, 0 and which side it's really on. So I don't think I'll pick 0, 0 because it's too close to the line. Let me just go out here a little ways, maybe pick something clearly not on the line, like 4, 2, to determine the shading. So y of 2, x of 4 is what I'm testing. That's my question. Is 2 bigger than negative 12 plus 1? Is 2 bigger than negative 11? Is my question. And the answer is yes, it is. So that means I should shade this way. Towards the 4, 2. Okay. Now we'll come over here and we'll graph this guy. So I can see if I put an x of 1, y would have to be 0 to give me 1. If I put an x of 4, 4 minus 3 would give me 1. Okay, so here's 1, 0. Here's 4, 3. Let me erase that. 4, 2. Here's 4, 3. You know, I could have done, 2, 1, right? Any coordinates that I subtract and get 1 would have worked. This one is solid. So this one is solid. So I'm just going to do something like that. Right, then for the shading, again, it's, oh gosh, it's kind of close there. I don't think I'm going to use that. I'm going to come out a little bit, 1, 2, 3, 4, 5, maybe out to 6, 1 or something. Just a point that is far away from the line. And I'm going to go to the inequality that I had here, and I'm going to plug in a 6 and a 1 for the x and the y and see if that's true. And it is. 5 is bigger than 1. So that means I need to shade towards that 0.61. And then I need to look for where the red and the blue arrows, see, I've got these 4 regions, and I need to see which region to shade. Let me do it in black. The actual solutions are in here. Okay, so the points on this portion of this line, okay, the point of intersection is not a solution, and neither are these. That's what the dash means, but all the points here would. Okay, all right.